Today we are going to talk about our part 3 operators and decision constructs, and within that we are going to talk about part 3.1 operators in Java, precedence, increment and short circuit logic. It's quite an important topic here. So this comprises of around 12 to 13% of questions that come in the Java OCA exam. Okay, so we have given earlier videos also here. You can look at them. We have given the links here. So what is operator precedence? It's like you have to think of operator precedence like Java evaluates expressions using operator precedence, right? It's similar to BODMAS in mathematics. What is BODMAS? BODMAS is an acronym used to remember the order of operations in mathematics. It's brackets, orders, order means powers and roots, then division, multiplication. Division and multiplication are left to right, and addition and subtraction left to right again. Okay, so that's called BODMAS. So it's again, if you remember, brackets, orders, division and multiplication, addition and subtraction. So operators with higher precedence execute first. If operators have the same precedence, then Java evaluates left to right. The most important rule for exams is that parenthesis, it overrides precedence. Anything inside the parenthesis is evaluated first before other operators. Okay, so when expressions look complex, mentally add parenthesis based on precedence, then evaluate step by step. In tricky exam questions, parentheses are often used to change the evaluation order, so always look at the expression very carefully. So let's walk through the main operator precedence levels in Java. Postfix operators x plus plus and x minus minus have the highest precedence, basically plus plus and minus minus. Okay, those are called postfix operators because they are coming after the variable name, right? So these operators use the current value first and then perform the increment or decrement. For example, if you have int x is equal to 5 and you write int y is equal to x plus plus, so what will happen? It is supposed to do post increment, right? So it will put x's current value, that is 5, into y, and then it will increment later. So after execution, y will become 5 only, it will not become 6 because it's a postfix, right? And then x become, after that x will become 6. The value is used first and then the increment happens afterwards. So next comes unary operators such as plus plus x, minus minus x, not, and unary minus, right? These operate before the value is used. So whatever value is there, they operate before that, right? For example, in case say int x is equal to 5 and int y is equal to plus plus x, right? X plus plus is coming before x, the variable, right? In that case, if x's value is 5, it will get incremented to 6, and that 6 will get assigned to int y. Here x is incremented to 6 first and then the value is assigned to y. After that comes multiplicative operators, that is division, multiplication, modular. These follow normal mathematical rules. That is, example, int result is equal to 10 plus 4 into 3. What will happen? First 4 into 3 will be worked on, right? So that will become 10 plus 12 and then it becomes 22, right? So like that it will work. Next are additive operators, plus and minus, which are again evaluated from left to right, like say int x is equal to 20 minus 5 plus 2. In this case, left to right, right? The 20 minus 5 is equal to 15 plus 2 becomes 17. Finally comes the relational operators such as less than, greater than, like that, right? Less than, equal to, and greater than, equal to. These are used to compare values and produce a Boolean result. For example, 5 greater than 3 equals to true, well 5 less than equal to 3 equals to false, right? Next we have to discuss about equality operators. Equals, equals and not equals, we check whether two values are equal or not. For example, system.out.println 10 equals 10, right? It will print true, while system.out.println 10 not equals 5 also prints true. After that is the logical and an operator and which are called short circuit and, right? So both conditions, in this case, both conditions must be true for the overall expression to be true. Okay, for example, if age is greater than 18 and then citizen equals true, if the first condition is false, Java doesn't evaluate the second condition at all. Then comes logical or operator. And also it's also a short circuit operator. Only one condition needs to be true. For example, if score is greater than 90 and then short circuit OR, then grade equals A. If the first condition is true, then Java keeps evaluating the second one. And next is the ternary operator. That's question. Which is a compact form of an if-else statement. The syntax is condition, then question mark, then value 1, then colon, then value 2, right? For example, int max is equal to within bracket a greater than b, then question mark, the a colon b, right? So if a is greater than b, that is the question, the condition becomes true, then max will become a, right? Otherwise it will become b. Finally comes the assignment operators such as equal to, then plus equals, and then minus equals. These have the lowest precedence. For example, int x is equal to 10, x plus 5 is equal to 5 is equivalent to x is equal to x plus 5, resulting in x is equal to 15. Assignment is evaluated after other operations are completed. Then we are going to discuss about two operators which are completely having different behavior, right? So this is one of the most commonly tested topics in OCA. So let me be very clear about what these two operators do, because students mix them up constantly. Post-increment is x plus plus. The current value is used in the expression first. We have to remember that the current value is used in the expression first, then x is incremented. So if x is 5 and you write int a is equal to x plus plus, in that case a will get 5, not 6. After the assignment, then x becomes 6. The increment happens after. And pre-increment is plus plus x. X is incremented first, then the new value is used, like we have discussed already. So if x is now 6 and you write b is equal to plus plus x becomes 7, and then b gets 7. Okay. Next is pre-increment versus post-increment, the code trap. This is a combined trap in case, say, you have a question like int result is equal to x plus plus, then plus plus x. That is x, where x starts at 5, right? So left side of x, left side x plus plus, it will evaluate to 5, right? Because that is a post increment. Then after that evaluates to 5, and then x will become 6, right? And right side plus plus x, in that case is already x is equal to 6, it will become, so plus plus x will make it 7, right? Evaluates to 7. So add them, 5 plus 7 is equal to 12. X is what? X is 7 now. Okay, so we have to remember that this exact pattern appears in exam questions. Trace it step by step, never skip. So it is not 6 plus 7, it will be 5 plus 7. Next we are going to discuss about compound assignment operators, the hidden cast. So this is a common Java exam trap involving small numeric types like byte and short. The issue arises when arithmetic operations promote this type to int, right? So suppose you have a variable declared as short s is equal to 5 and you try to write s is equal to s plus 10. Java first evaluates the expression s plus 10, and during arithmetic operations Java automatically promotes the operands to int. The result of the expression therefore becomes an int, not a short. Now Java tries to assign that int result back to the short variable s, but that will require a narrowing conversion because an int is larger than a short. Since Java does not perform this narrowing conversion automatically, the compiler produces a compile time error. However, if you write s plus equal to 10, s plus equal to 10, then the code compiles successfully. This is because compound assignment operators like plus equals, minus equals, multiplication equals, etc., they include an implicit cast. The compiler automatically casts the results back to the type on the left side. In effect, the statement s plus equals 10 behaves like s is equal to short, then short cast, then s plus 10. Okay, so this behavior often appears in Java certification exam questions. If you see arithmetic involving byte or short, always check whether the code uses plain assignment equals or combined assignment plus equals. Likewise, plain assignment usually requires explicit casting, while compound assignment handles the cast automatically. Now we are going to discuss about short circuit operators and or. Short circuit evaluation is a concept that often appears in Java exam questions. The logical AND operator and works so that if the left side is false, the entire expression cannot possibly be true. Java recognizes this and stops evaluating immediately, skipping the right side. This behavior matters because the right side might contain a side effect such as x++ or a method call. If the right side is skipped due to short circuiting, the operation never runs, so variable remains unchanged. The logical operator or behaves in the opposite way, right? If the left side is true, then the entire or expression is already true, so Java does not evaluate the right side. In contrast, the operators and or, that is single ampersand and single pipe, are non-short circuit operators, right? They always evaluate both sides of the expression even if the result is already known. This distinction is important when expressions include increments, assignments, or method calls. In exam problems, you may be asked to determine the final value of a variable after such expressions. The key question to ask yourself is, was the right side of the expression actually evaluated? Understanding this helps you predict whether a side effect occurred or not. Now let us discuss about modulo and arithmetic key rules. The modulo operator, that is the percentage, returns the remainder after division, right? For example, 5 modulo 3 equals 2 because dividing 5 by 3 leaves a remainder of 2. Similarly 10 modulo 2 equals 0 because since 10 is exactly divisible by 2 and nothing is left over. A case that sometimes surprises people is 7 modulo 10, right? The result is 7 because 10 goes into 7 0 times, so entire value of 7 remains as the remainder. The operators like star, division and modulo all belong to the same precedence level in Java. Because of this, Java evaluates from left to right when they appear in the same expression. For example, consider the expression 5 multiplication 4 modulo 3, right? So it will be evaluated left to right, so it will become 20 modulo 3. So what will happen? So after the first multiplication, it will become 5 into 4 is equal to 20. Next, Java will evaluate the modulo operation 20 modulo 3. Since 3 goes into 26 times, 2 will be left over, remainder, so final result is 2. Parentheses act as an override mechanism for operator precedence in Java, right? When a sub-expression is placed inside parentheses, Java evaluates it before applying the normal precedence rules. If there are multiple levels of parentheses, the innermost expressions are evaluated first. The evaluation then moves outward. This rule is important when dealing with complex arithmetic or Boolean expressions, especially in exam questions. Parentheses can change the order in which operations are performed, therefore change the final result. In certification exams also, you may see long Boolean expressions involving several operators. The safest approach is to mentally group the expression using parentheses according to operator precedence and then evaluate them part by part, step by step. Sometimes exam writers intentionally include extra parentheses to make the expression appear confusing. However, parentheses simply force certain operations to be evaluated earlier. By carefully reading the expression and following the parenthesis structure, you can very easily determine the correct result. So here in the screen also, in the last example, if you see Boolean D, right? True or false, then and false. True or false, then it becomes true, then and false, so it will become false. Right, anything false there in that expression, it will become false. And here true and then false and then false, the last example, then it becomes true or false and then false, it becomes true or false, the result is true. Let's have this practice question now. So you see int x is equal to 5, int y is equal to x plus multiplication 2 plus x. What is printed, right? System out println y and system out println x. First we have to print out y and we have to print out x. So if you do a trace x plus, what happens is that x plus initially it will use x only because as a post increment it will use 5. That will be multiplied by 2. 5 into 2 becomes 10 plus here 5 has already become 6. Then it is doing a pre-increment, so it will become 7. So we are having 10 plus 7 is equal to 17, right? So y will print 17 and whereas x will print 7. So what is the output? A, 17 and 7. If you want more, you can practice many questions. 1624 questions are there at https://javalearn.clustermicro.com. You can visit that website, enroll yourself and do all the practice there. We have 29 full-length practice tests available, timed.